All right, so let's start by just knowing what secant, cosecant, tangent, and cotangent are. So secant is 1 over cosine. Cosecant is 1 over sine. Tangent is it's sine over cosine. And cotangent is cosine over sine. All right, so that's what we have to solve for. So we need to know what sine and cosine are in order to solve this problem. Your life is made easier if you have the unit circle memorized. So here it is. I recommend memorizing it. If you don't have it memorized, though, you can still solve this. So we're going to still need a circle, and it's still going to have to be a unit circle, as they are, drawn on a coordinate grid as such, because this is how we understand trigonometry. So normally, we go counterclockwise, right? This would be 0, pi halves, or 90 degrees, pi, or 180 degrees, and so on and so forth. But we're going to have to go counterclockwise in order to go negative. So this is going to be negative 45 degrees, negative 90 degrees. This is negative pi fourths. This is negative pi halves. And this here is going to be negative 135 degrees, or negative 3 pi over 4. Oh my gosh, look at that. That's the angle that we need. If you don't understand how I got here, that's a longer conversation. Shoot me a message. Let's chat. But let's just go forward from here. So in order to find what are sine and cosine, we need to use this triangle here, because this distance, this vertical distance, this is sine, and this horizontal distance, this is cosine. So we're going to come back to that. Let's first solve this. So we know that this here is a 45-degree angle. How lucky! This is a 45-degree angle. This is a 90-degree angle because we created that triangle. And this, again, is a 45-degree angle. Ooh, we have a special right triangle happening. So if you recall, if the legs are each x, then the hypotenuse is going to be x root 2. So, again, this is the unit circle. So we know that the hypotenuse is 1. So 1 equals x root 2. So x equals 1 over root 2 equals root 2 over 2. However, so again, I'll back up. So that means that this guy is root 2 over 2, and this guy is root 2 over 2. Okay, so sine and cosine are both root 2 over 2. Almost, not quite. So in this quadrant here, quadrant number 1, sine and cosine are both positive. Here in quadrant 2, however, cosine's negative, sine's still positive. Here in quadrant 3, where we sit today, this vertical distance, you'll notice, is downward. This horizontal distance is leftward. So sine and cosine are both going to be negative. So they're negative root 2 over 2 and negative root 2 over 2. But that's what we needed to know. So we needed to know that sine theta is negative root 2 over 2, and cosine theta is the same. And that's going to help us solve the rest of these. So 1 over cosine theta, which is secant theta, is 1 over negative root 2 over 2. And that's going to be 2 over negative root 2, which when we simplify by rationalizing the denominator is just going to be negative root 2. Sine would be, cosecant, or 1 over sine, would be the exact same thing. Tangent is sine over cosine. These guys are the same, which makes sense because it's our 45, 45, 90 triangle where the legs are the same. So this guy is just going to be 1, same here. So I kind of just sped through that. I'm hoping it all makes sense. If you don't understand the radian to degree conversions that I did, if you don't know why I did this on a circle, any of those things, shoot me a message. I'm happy to explain more in depth, but I'm hoping that just helps you understand the answer to this problem. Best of luck.